Hello geometry class. I got the surveys, a lot of responses I got, so I got a suggestion that I should be including textbook examples, and I would do that. So today we are going to do the journal problems from section 9.3, similar right triangles. Afterwards we are going to tomorrow I would explain the problems examples from the journal. So we are starting from question number 1. That says our first question is identify the similar triangles. And our one of the theorems says that if we drop a perpendicular from vertices where the right angle is formed to the hypotenuse, that's going to be divided into similar triangles, and those two similar triangles would be similar to the original one. So we need to know how to write down the expression, like what's the correct order. So just a quick trick how to do it. Very first thing, if you have to write the name in right order, so you pick this triangle and keep in mind you keep your starting point here, because it's so sometimes it's confusing to pick how to name it. So I would be naming HJK. So my first triangle is triangle HJK is similar to triangle. Then you pick the second triangle. So let me make it bigger. Yes, it's shaky because my camera it's on a cell phone holder, so when I just try to make it big it starts shaking. I'm sorry for that. And then and then we have another, this one, that is you start the naming of this triangle. How do you start? You start from here, you start like this, go like this, and go like that. So that's why I have created the arrow. So you start from here for this triangle and you name it JIK. Is similar to triangle. Then we need to write the third triangle. And how do we name the last triangle? To name the last triangle, we pick our final one, this bigger one. How to name this one? We start from here and we name it like this. It goes like this. So we start from here, but we name in this direction. So it's going to be HIJ. Alright, so this way we have to do it. So let's move to the next problem here, this one. And how to do it? Again, I said you can just imagine it. If I rotate the page, I told you whenever it's not convenient, rotate the page and see. The same logic I said how to name it. First triangle is NMP, this one, NMP. Second one going to be MOP, like this one. And the original one will go this side, NOM. This way we will say the name. So let me write down the names for these triangles. This is going to be, the first triangle is going to NMP. That's similar to triangle MOP. And that's similar to triangle, the bigger one, NOM. Alright, so that's the answer for this question. I hope you get it. Let's move to question number 3. What we have to do, we have to find the geometric mean for this. And I told you geometric mean, what it is, just multiply and take the square root. So geometric mean for this is going to be just multiply the numbers, take the square root. Now whenever you have this situation, you can do one thing, either you get 12 and then get the square root. And the method I told you to do the square root is just to factorize it and make the pairs. 2 can be factorized further, but 2 times 3. And make a pair here for every number, as many pairs you can make. And that's actually 4. Square root of 4 is what? 2. So it's like square root of 4 times square root of 3. So that's actually 2 root. So in simple words, just bring out one number for a pair. So 2 root 3. That's our answer for this question. All right. In this case, if I have to find, so that's going to be square root of 5 times 45. And how to do it? Again, I told you, you multiply and then get the square root, but let's make it easier. 45, just recall, 45 is in table of which number? 5 and 9, or 5 times 9 is what? 45. I factorize it further and 9 again. Is the 9 can be further? Yes, that's 3 times 3. So I would be making pair of, so this is 5, one pair, and other pair, this is 3. So that is what, this is 25 and this is 9. Square root of 25 is 5. So you just bring out 1, and square root of 9 is 3. And that is what? 15. I hope you get it, or if you like your own method, you can do it that way. This is easier. That's why I'm sharing with you. All right. After this, we have another examples, another questions where we have to use altitude theorem, a leg theorem, or those kind of theorems where geometric mean has to be found, but sometimes it's for altitude and sometimes it's for leg. So when I just go back to the question, I see I have to find altitude, and right away I have to think about, have we done any theorem like this? Yes, we have done, and let me show you altitude theorem. What does it say for this one? Altitude, in order to find altitude, you just multiply the segments of the hypotenuse and take the square root. So it's the geometric mean of these two segments. Altitude square, or altitude, is geometric mean of these two segments. Same way for leg theorem, if you are finding any leg, that is actually the segment of the hypotenuse towards that leg times the whole hypotenuse. So if I'm finding AC square, that's going to be AD times AB the whole. If I'm finding CB square, that's going to be DB times AB the whole. So the way we are going to use these two in the questions here from 5 to 6. So how to do it? I have to find this, and I told you that's the hypotenuse, and our segments are this. So you can just imagine, you can look at it this way. I have to find this thing, so this square is this time this. Great, so let's apply that. So I can write down x square is 16 times 9. And what is x? Take the square root of both sides, 16 times 9. And after that, it's your choice how you want to solve it. We can do it by just, we see both are perfect squares. So 16 is 4 times 4. I know that. 9 is 3 times 3. But if you want, you can do it directly, just showing you more steps. And that's going to be what? 4 times 3, that is 12. Or if you just want to multiply, you get 144 here, and square root of 144 is 12 here. Alright, so that's the value of x. Now that was altitude, that was geometric mean altitude theorem. So I would write down the name geometric mean altitude theorem, so that if you want to confirm which one I have applied, you can always check it. So GM means geometric mean. I just use it so that you don't, so this is geometric mean. I'm just using an acronym for that. For this question, now here they're not talking about altitude, they're talking about leg. So we're using geometric mean leg theorem. All right, we have to find this leg. And I told you geometric mean leg theorem says whatever the leg is, you're supposed to take the segment of the hypotenuse towards that leg, not this one. We're taking this one, and then you have to take the whole. So I need to know how much is the whole. So I have to find the hypotenuse here. Hypotenuse is what? Because they gave us the parts, they haven't given us the whole. 9 plus 2 is 11. So now I know the whole is how much. So when I apply the theorem, y square is what? 9 times 11. That is what? I see that 99 is not a perfect square of something. That 9 is the square of 3 and 11. I can make a pair. It's 3 root 11. I hope you get it. Let's move to the question number 7. 7 is kind of it's kind of more taller. So whenever you have a doubt, my suggestion just to rotate the picture and see in a normal way, like which kind of theorem I could apply here. I see this is altitude given here, altitude here, but actually we need to find the leg is given and the part of hypotenuse is given and the whole hypotenuse. Whenever the leg is given, we are supposed to use the leg theorem. So what it should be, this is given, this is equal to part towards the leg, the part of the hypotenuse, times the whole hypotenuse. We're going to use that. This square is this time this. So we are going to write it here. So I can write 49 square equal to, this is 7 times t. Alright, and let's switch the sides. It looks easier when we do it. 7t is 49 square and t is what? 49 square can be written as 49 times 49, and divide both sides by 7, you get 7 here. You do the cross cancellation, 1s and 7s, and t is going to be, when you multiply it, your answer is going to be 343. All right, I hope you get it. Let's move to the very last problem here in 8. That is, actually you can look at it and see. If you find it confusing, I told you always rotate the book and look at it in a normal way. I've been given the altitude and I have been given the parts. So it looks like geometric mean altitude theorem. So this square is this time this. So we apply that, we move it, and then we check it here. We say this 6 square is what? Part time this part time this part. So 3 times a plus 4. And let's switch the sides. I like the variable on the left hand side, and that's 6 times 6. You make it 36. And then distribute it. 3a plus 12 is 36. Subtract 12 from both sides. 38 is, you subtract it here and you get 24. And a is 8. Divide both sides by 3. Your a is 8. I hope you get it. Try to practice these problems. So as per the suggestion, I would be tomorrow discussing more problems from the textbooks so that you get more exposure of different kind of problems. And stay safe and healthy. Till then, bye. Let me know any question. Bye.